All right, eyes on the screen. How goes it, everybody? So make sure the tables are filled out on the first page, which we did yesterday, second page, third page. Use your calculator to plug in those larger and larger numbers. And then do me a favor, maybe throw in 10,000 in there as well. I think you guys are seeing what's happening. I'm actually going to not share this so you can see. It'll be next week. Yeah, there's a lot of time in this. Okay, I want you guys to look at the first page here, this first page, the one that we filled out yesterday. And I want you to look at number 1, the 2x plus 3 and the x plus 5. So here's how I want you to think about what we're going to do today and into tomorrow. This is kind of my favorite series of talks here. One of my favorite series. I love this course. So I want you guys to think about if you were a millionaire, if somebody had $1 million, and you gave them $5, okay, would they care? Would a millionaire care if they got $5? Let's go even bigger than that. Let's go even bigger than that. What if you were a billionaire? What if you were a billionaire? Would you care about getting $5 if you look at the denominator there? So let's say you had $1 million or $1 billion. Say you had $1 billion and somebody gave them $3. Would they care? Would they care? Okay, no, they wouldn't. So think about this. If you had, say, Beyonce and Jennifer Lopez, I've used this example every year that I've taught horizontal asymptotes and vertical asymptotes, but horizontal asymptotes in particular. Beyonce, I forgot which one was higher, which one was worth more, but who was worth more, I should say. But Beyonce and Jennifer Lopez, one is worth like $250 million, and this is like 3-4 years ago. I'm not going to check again. And the other is worth $300 million. So let's say that's Beyonce. Okay, it could shift. It depends what they're doing. It depends when they're you know, whether they're acting or I know Beyonce's taking a break. I think she just had a baby or babies, like twins. I don't really follow that stuff. But depending on the year, their net worth could actually go up tens of millions of dollars. So essentially, Jennifer Lopez and Beyonce have the same amount of money. Even if one is 350 and the other is 250 million, even $100 million difference, they essentially have the same amount of money. What do I mean by that? Even if they needed the most dire medical procedure, that'll only run into, you know, several $1 million, barely even 10 million. In fact, I think the most expensive medical procedures over years are still around $10 million. But he was very, very ill for a long time. They can afford literally every car, every helicopter, almost every yacht, almost every building. Okay, they can't buy everything. I know that. There's things that are worth billions of dollars. They can't buy the island of Manhattan, okay, which is worth hundreds of billions of dollars, I imagine, in terms of the real estate. But they can buy essentially anything, okay? Even things that just give us like pleasure, like, you know, like very fancy cars or fancy homes with too many rooms and bathrooms, etc. So they have the same amount of money because they have so much money. It's so large. So let's get to this here. So if you had $1 million and somebody gave you $5, you really wouldn't care. If somebody had $1 million and somebody gave you $3, you really wouldn't care. But what if somebody was going to double what you have? What if somebody gave you another $1 million on top of your 2? Take a look at that 2x plus 3. What if you had $1 million and then somebody doubled it? Would that matter? Would it matter if somebody doubled how much money you had? Yeah, it would. It would. You'd have $2 million. You're doubling what probably is your worth. Okay. We could think about it even in another way. If a company is in debt, if a company's in debt $80 million because of, you know, say bad business decisions, or they had a merger that didn't work out, or they spent a lot of money on a merger and they're trying to hope it brings them a profit. If a company's $80 million in debt, do they have to stop the $4 or $5 coffee a day the CEO has? If the CEO has a $4 or $5 cup of coffee every day, they're $80 million in debt. Is that going to change anything? Is that going to change anything? If a company's $80 million in debt and they still buy $5 coffee or anything? No, it's pretty much at the max, okay? And I'm going to talk about, say Mark Zuckerberg of Facebook or Jeff Bezos of Amazon. I mean, they're worth billions of dollars, tens of billions of dollars. So if they, if you gave them $3, would it really matter? Okay, maybe for Jeff Bezos it does because he's getting divorced. Yeah, I went there. So if I gave somebody like that $3, it's not going to make a difference. Okay, so let's get to more of the math part of this. So just listen. Just listen. If you want to rewatch this and take notes, fine. But just listen to how I present all of this. It's a little bit of a review, but then we're going to get into the actual topic here. So you guys know, you've seen this before. An asymptote is a line or curve. Okay, we're not going to do curves in this course. An asymptote is a line or curve where the graph gets arbitrarily close. The graph gets arbitrarily close, but never touches. So an asymptote is a line. All right, see how far the bullet points off because I made the emphasis. We're not going to get into curves in this course, but an asymptote is a line. Please, guys, you have to have x equals something or y equals something. I've said this many times. It's got to be a line. You can't just say 1/2. You can't just say 5. It's got to be x equals 1/2, y equals 5, etc. So to solve for a vertical asymptote, which you guys have done many times, you set the denominator equal to 0 and solve for x. All right, so let's do a quick one right here. Oh boy, I didn't realize it was going to go like this. Didn't go like this in last year's. If we have 5 over x squared minus 81, what is the asymptote or asymptotes? All right, you just got it marked wrong. You just got it marked wrong. There you go, x equals. It's got to be x equals -9, x equals 9. X equals -9, x equals 9. Good, because you'd factor and then solve. All right, likewise, what are the vertical asymptotes here? Just vertical asymptotes, not talking about horizontal. Good, yeah. X plus 6, x minus 6 are the factors, and then you set it each equal to 0. So let's get into the rules of horizontal asymptotes now. So with horizontal asymptotes, the reason I started talking about J-Lo and Beyonce, is she even called J-Lo anymore? Jennifer Lopez, Beyonce worth hundreds of millions of dollars, Mark Zuckerberg worth about 70 billion, Bezos worth about 140 billion. I'm sorry, it'll be 70 billion really soon. Yeah, I went there again with a divorce. So I want you guys thinking big. I want you guys thinking as big as your dreams. I want you guys thinking as big as your dreams. And what do I mean by that? I want you thinking of the distances between galaxies. I want you to think about America's entire economy. I want you to think about a corporation's debt. And I want you to think, how long ago were the dinosaurs? Okay, so let's look at some of these answers here. Distances between galaxies are trillions of miles. The America's entire economy, which we judge whether we're in a recession or we're in a period of growth, the GDP, that's trillions of dollars. All right, a corporation's debt is billions of dollars. How long ago were the dinosaurs? That's millions of years ago. Now, one thing to note, a corporation's debt, how long ago were the dinosaurs? We're not going to really talk too much about negative numbers. We're not going to really talk too much about negative numbers here, okay? I want to talk about putting in like just positive large values in. Positive large values in for x. Okay, so take a look at this. We have 2 over 1, 3 over 1, 40 over 1, and 50 million, excuse me, over 1. So this seems a little ridiculous. I'm just saying that when you go on the number line, 2, 3, 40, 50 million, you could see that the numbers get bigger. That's why I have less than symbols here. I have them over 1 because I'm showing that any number can be made into a fraction, right? Okay. So as the numerator gets bigger, what are we approaching? As numerator gets bigger, okay, I'm sorry you're having equipment malfunctions, but you need to listen. You need to listen. As the numerator gets bigger, what do we get close to? What number are we getting close to here, guys, as we go from left all the way to right? Yeah, we're getting close to infinity. That's why I tell you guys, on a graph, infinity is all the way to the right. Okay. Now, you're going to have to rewatch the lesson then. I can't help you. I've got to get through this. You guys already had to move classrooms, and it cost us 6 minutes. Thank you. Now, rules of horizontal asymptotes. Now let's look at if we have the opposite situation. Instead of the numerator getting bigger and bigger and bigger, while the denominator is essentially remaining the same or is remaining the same, let's talk about the denominator getting bigger and bigger and bigger until we get really, really, really huge. We're going to get really, really huge. Okay? So as the denominator gets bigger, what are we approaching? Put in the chat box. Be careful. What are we approaching? Take a look at what's on the right after these equal signs. Yeah, we're getting closer to 0. We're getting closer and closer to 0 as the denominator gets bigger and bigger and bigger. Okay, so take a look at this function. Sorry, it's x over x squared. Don't simplify it. Don't simplify it. We're going to plug some stuff in here. Yeah, we're not going to simplify it, though. Yeah, x over x squared. Okay, we're not going to simplify it. Oh, goodness, why did this happen? Okay, so if you were to put 5 in for x, if you were to put 5 in for x, you'd have 5 over 25, right? And that reduces to 1 over 5, and that equals 0.2. That is not close to 0. That's not close to 0. By the way, are we recording this? Yeah. I cannot wait to do the blue button on the canvas, which you used once or twice when Blackboard was down. I can't wait for this. This never happened with Blackboard until this year. Okay? So if you put 5 in for x, you'd have 5 over 25. That's 1 over 5. That's 0.2. That's not close to 0. Okay? I'm not talking about putting 5 in for x on any of this stuff. Okay? I'm talking about putting enormous numbers in for x. Okay? When I'm talking about horizontal asymptotes, we're talking about putting enormous numbers in for x. We're just dealing with the positive right now. That's it. Okay. So let's take this x over x squared, and let's put an enormous number in, like 1 million. So if you were to put 1 million into the numerator, sorry, it's a little hard to say, we'd have 1 million in the numerator, but we'd have what in the denominator? What number is this, guys? 1 million squared is what? Yeah, McKinley's on the right track. That's what we're essentially doing as we get bigger and bigger. What's this number on the bottom here? We have 1 million on the top. What's 1 million squared? What's 1 million squared? Yep, that's a trillion. Yep, 4 sets of zeros. 3 sets of zeros is a billion. 4 sets of zeros is a trillion. Speaking of rich men, nobody's been a trillionaire yet, and Jeff Bezos was on pace, but looks like no. I went there a third time. I only planned on one joke. 1 millionth. 1 millionth. 1 over 1 million. Okay? So with horizontal asymptotes, whether it's a denominator bigger or the numerator that's bigger, or maybe they're both the same. You'll see that in a second. We're talking about putting in enormous numbers. We're putting in enormous numbers. And this million to trillion is going to be a good example. Okay? So you basically have 1 millionth, even when you put a million for x. Okay, so now we're close to 0. Now we're close to 0. You can see how close we are to 0 with this. When you put 5 in, it doesn't work. Okay, when you put 5 in, it doesn't work. So what happened here? So as we went from x equals 5, which was 5 over 25, to x equals 6, which is 6 over 36, we didn't do that, and then x equals 1 million, what happened? What happened? The denominator got bigger faster than the numerator. Take a look at that bottom line, which hopefully you can read. The numerator got big. The denominator. The denominator got bigger faster than the numerator. That's what's happening here when you have a higher power of x in the bottom. Let's get away from these monstrosities. Okay, now a little bit easier to see. So this is what I'm talking about. If you gave a millionaire $5, if you give a millionaire $5, that really doesn't matter. That really doesn't matter. It's not going to move things one way or another. Take a look here. If you had 1,000,005 over 1 trillion, if you have 1,000,005, you can see how far it is away. If you have $1,005 over 1 trillion, you still essentially have 1 millionth, and you still are essentially at 0. Good. Yeah, the exponent makes all the difference. So watch this. What if you, and it does matter to a millionaire. It does matter to a millionaire. What if you increased a millionaire? What if you increased a millionaire's by 10? What if you had a millionaire and all of a sudden you gave him another $9 million? I'm talking about asymptotes. Another $9 million. You have a millionaire that's a $9 million. What do I mean by essentially 0? Look at what is on the screen here. 0.000001 is essentially 0. It's essentially 0. There we go. So if you were to give a millionaire another $9 million, Okay, you were going to increase his net worth by 10 times. That would make a big difference to him. Here's the problem, though. $10 million over what's 1 million squared, guys? $10 million over a trillion is still 1/100,000th. 10 million over a trillion is still 1/100,000th. That's essentially zero still. That's still essentially zero. So I'll let you know what I'm getting at here. The power of x is so much bigger than putting 10 in and multiplying. Okay, the exponent is really, really powerful, as small as it is when you like type it and write it. Okay, so take a look at this quadratic on top of a cubic. All right, and it's written similar to this, like 10x over x squared, a higher power of x in the denominator. So we have a higher power of x in the denominator. Now, watch what I'm going to do here. I am not canceling. I'm not canceling. I'm taking a guy with $10 million, and does giving them $2 make any difference? No, it does not. No, it does not. In fact, none of these things matter. The only thing that matters is what the exponent is on the x and maybe the coefficient. So look at what I'm doing here as I'm graying stuff out, as if I'm Thanos with the Infinity Stones, okay? I'm graying all this stuff out, saying it just doesn't matter. It just doesn't matter. All that matters is the highest power of x in the numerator and highest power of x in the denominator, okay? Again, a reminder, this is only for putting enormous positive or negative numbers in for x. So even the 10 in front of the x squared doesn't matter. The only thing that matters is the highest power of x in the numerator and highest power of x in the denominator. If you get 12, if I say, hey, what's x equals 12, you got to input it into the whole thing, even the stuff that's gray here. Okay, 12 is a small number. I'm talking about putting millions and billions and trillions of miles between galaxies into numbers. Okay, this is for enormous numbers. Okay, so if you put an enormous positive number in for x, guess what? You're essentially going to get 0. You're essentially going to get 0, because the only thing that matters is putting in a million in for x squared, which becomes a trillion, and then you put a million in for x cubed, okay, which is going to be 1 sextillion, I believe. Yeah, I think sextillion is the right one. It's going to be way, way bigger. Okay, now watch this. Watch this. Take a look at what I have here. The highest power of x in the numerator is x squared. Highest power of x in the denominator is x cubed. I'm going to switch them now. The numerator now has the highest power. So you can essentially ignore everything else except x cubed and x squared. So the numerator is now going to get bigger faster than the denominator. You know what essentially this is? We're getting bigger and bigger numbers into x. This is essentially infinity. Although we're getting into the Precal stuff now a little bit. This is essentially infinity. The numerator is going to get bigger faster than the denominator, because now the highest power of x is in the numerator. I think you guys are following this. So now let's get to Coco, Bobo, and Botan, our really creepy, scary clowns. Especially not in color, they're a little nicer. So Coco stands for, and I'm going to have to put show PDFs of this. Coco stands for the coefficient over the coefficient when the largest power of x is the same in the numerator and denominator. The horizontal asymptote is the ratio of the coefficients. What? We're going to take these notes tomorrow. We did this one yesterday, right? Yeah, we did this one yesterday. When the largest power is the same in the numerator and denominator. Okay, so that was when you had 2x plus 3 over x plus 5. 2x plus 3 over x plus 5, take out the plus 3, take out the plus 5, and you have 2x over x. 2x over x reduces to 2. That's why y equals 2. So what's the horizontal asymptote going to be for this example, which thankfully is clear? The largest power of x is the same in the numerator and denominator. What's it going to be? Okay, let's write the whole thing out. What's the horizontal asymptote going to be? Shame on us for not putting that. Y equals 3 over 2. Yeah, everything cancels out. Everything cancels out. Now, let's talk about BOBO. BOBO stands for bigger on bottom, and we'll take these notes tomorrow formally. Bigger on bottom means the highest power of x is in the denominator, which is the first example I gave today. The highest power of x is in the denominator. So what's the horizontal asymptote going to be? What's the horizontal asymptote going to be? It's a little hard to read there. Okay, it's going to be y equals 0, or what's it say here? It's a little tough to read. It's going to be y equals 0 or the x-axis. Be careful. Be careful. Do not call this 1/5. What's the mistake saying y equals 1/5? What did you not look at first? You're not following the rules. What did you look at first? What did you look at first? If I said y equals 1/5, what did I make the mistake? What did I think was going on? Yeah, I just looked at the coefficients. You have to look at the powers of x first. And that's what Latin is. Bigger on top, there's no horizontal asymptote. It's called unbounded. It's called unbounded. So if I have x to the 5th up here, it doesn't matter that I have x to the 3rd down here, let alone -2, +1, -4x, +4x. All that stuff doesn't matter. We're putting in huge, huge numbers in for x. So here are the rules. Coefficient over coefficient, bigger on bottom, bigger on top, none. And we're going to write this out tomorrow. Okay. So let's find some horizontal asymptotes. What's the horizontal asymptote for this, guys? Remember, asymptotes are lines. What's the horizontal asymptote for this? Nope, bottom does not have a slant asymptote. Bottom will not have a slant asymptote. What's the horizontal asymptote for this? Y equals 0. Good. Y equals 0 or the x-axis. Y. Because the power of x is bigger on the bottom. Good. What about this guy right here? Horizontal asymptote only. Horizontal asymptote only. By the way, you can't do that. -3. There's no vertical asymptotes for this. Yep, y equals 0. Good. You see why vertical asymptotes? Don't get trapped. It's x squared plus 9. You put -3 in there, that's 18. Put +3 in there, still 18. All right, awesome. Well, I got the whole lecture in. Thank you. Thank you guys at Lola for being flexible. Sorry about some of the technical issues, and we'll pick this up tomorrow. Have a great day. Study, study, study. Rewatch this if you don't quite understand what's going on.